Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at binomial estimation. On the screen I have a value for x. Now this estimation is only going to work when x is less than 1, okay? So it also can't be equal to 1, it has to be less than 1. And we have here the x value of 0.1. Now I've took that x value just to use it as an example. That is just an x value that is less than 1, okay? And what I'm going to do is I'm going to raise x to some different powers. We can see I'm going to raise it to the power 1, and then I'm going to raise it to the power 2, to the power 3, 4, 5, and then I'm just going to skip to the power 10, okay? So let's work through what those powers are going to give. X to the 1, we know that x is 0.1, so that's just going to give 0.1 to the 1. Okay, which of course is just 0.1. If I then do 0.1 to the 2, so x squared is 0.1 squared, that's going to give me 0.01. As we work through these, what I want you to do is just notice the value of the x squared or the x cubed. What happens as we increase the power? What happens to the value of the actual x to the 4 or whatever? Okay, so x cubed is 0.001. As you can see, we're just adding an extra 0 to the left, if you like. X to the 4, what that is 0.1 to the 4, so that's 0.1 times 0.1 times 0.1 times 0.1, which is of course 0.0001. X to the 5, we can see where this is going, is 0.00001. And then if I'm just going to delete that so I can jump to x to the 10. What is happening to the values as we increase the power? Okay, so as we go down, I'll write it in red here, the power is increasing, and I'll write it like that. So the power on the x is increasing as we go down the working there, okay? But look at the values that we've got on the right hand side here. They are clearly decreasing. Okay, and I'm going to write it like this. Values are clearly decreasing. So we can kind of do a little statement from what we've just done here. As we increase the powers of x, and remember x has to be less than 1, as we increase those powers, the values here on the right hand side, are decreasing in value. 0.01 is clearly greater than 0.01, which is clearly greater than x to the 10, which is 0.901. Okay? So this is the summary that we can basically say, and we can take 3 things from what we've just done. If x is less than 1, then x to the n gets smaller, so the values are decreasing, so they're getting smaller as our power, here is n, as n gets larger. So 3 things. If x is less than 1, x to the n gets smaller as n gets larger. So that's the summary that we can take from that, and we can use this to help us with binomial estimation. Binomial estimation is sometimes used in engineering or in science, and it's often useful to find simple approximations to complicated functions. Okay, so you take a function and then we can basically make it simpler and do some approximation on it. Okay, what this also tells us then is, because as we get a higher power here, as n increases, as that gets larger, x to the n gets smaller. So really, 0.00009 noughts there with a 1. That's basically, in an estimation, not really going to change the estimation that much. If you think about it, adding 0.0000001 onto something doesn't really, if you were to look at it at, 2 decimal places, it actually doesn't change anything. But if you just look at it as a whole, adding 0.1 to the 10 onto your number doesn't really change it, okay? It's not significant enough if you're doing an estimation, and that's why it's called estimation. So let's see how we can kind of adapt this to a question and how we can actually use estimation. I only have one example for this because I think it's pretty simple. What you will get in an estimation question for binomial estimation is possibly two parts. The first part is most likely going to be an expansion. So I've actually already done this expansion. If you want to pause and have a go, do. If you're unsure, have a look at a previous lesson where we go through the binomial expansion. So the first and final example for this video, actually, part A says find the first 4 terms in the binomial expansion of 1 minus x over 4 all to the power of 10 in ascending powers of x. So just really think about your expansion, and then if you don't get them in ascending powers of x, so if you use this as a and this as b, I think you will. But if you did it the other way around, if you had minus x to the 4 as your a and then 1 as your b and substituted it into the binomial expansion, you'd actually get descending powers of x. But that's fine, because then you can just flip all the terms around. But just make note of the wording in the question. It wants you to give your final answer as ascending powers of x. Part B is then where the estimation comes in. It says use your expansion to estimate the value of 0.975 to the power 10, giving your answer to 4 decimal places. So it's using your answer. If you can't do binomial expansion, you're not going to be able to do the estimation bit here. So have a go if you want to at part A, and then press play, and I will just show you the answer under the box. If you had a go, this is what you should have done. So let me get rid of the box here. I've already done it because we've done it in previous videos, and it's actually quite simple. You just follow the process of the binomial expansion. So let me quickly run through it. This was the bracket that we wanted to expand. We have the first term to the power 10. Then we have our combination of our multiplication there. So we have 10 choose 1. Our first term, we reduce the power each time, and then we increase the power of the second term each time. And that's how we come up with our expansion. Now, it just wanted the first 4 terms, so don't do any more terms than that. Just do the first 4 terms, because that's all it needs. And I've nicely labelled here, this is term 1, this is term 2, term 3, and term 4. Then all you need to do is just simplify your coefficients. So 1 to the 10, of course, is just 1. 10 choose 1. I'm not actually sure what 10 choose 1 is off the top of my head. Give me a minute. 10 choose 1 is, 10. And then 1 to the 9, that is just 1. And then we've just got this on the end of it. So we're just going to basically get a negative from here. 10 choose 1 is 10, so it's 10 divided by 4, which is 2.5. And of course, we've got the x there as well. Do the simplification for the other 2, and then this is your final answer for part A. Now, even though it's asked you for the first 4 terms, whenever you get a question like that, it's always useful to put plus ... on the end. If you don't do that, what you're saying is this expansion here of this bracket, or that bracket, sorry, is equal to, and let's just pretend we didn't have that there, is equal to those 4 terms. It's not equal to those 4 terms because you've got other terms as well. We just stopped at term 4 because that's all we were asked for. So make sure you do put ... to say there's other terms and it's not the end of the expansion, but I don't need to write them because the question hasn't asked for them. Okay, so just a ... there shows that you've got more terms. Okay, so that's the expansion. Then part B says use your expansion to estimate the value of 0.975 to the power 10, and we want it to 4 decimal places. What I want you to do is I just want you to have a look at the estimation that we are trying to do, and it's keyword estimate. Don't just type that into your calculator and write the answer down, because that's not an estimation. It's telling you to use your expansion. So look at what I've just highlighted in green there, and then compare it with this bracket here. 1 minus x to the 4, 1 minus x over 4 to the power 10, and 0.975 to the power of 10. We know what this bracket is in the expansion, or we just know its first 4 terms. I want to compare this with this. They're both raised to the power 10. So what I can do is I can set this part of the bracket equal to that decimal there, because that's the decimal that's raised to the power 10. If I do that, I can then solve an equation, because it's just going to be this equation here, 1 minus x over 4 is equal to 0.975. I can work out what x is, and then that's useful because I can just estimate this by substituting my x value into the expansion. Where you can go wrong with this question is just substituting this decimal into this expansion. But that's wrong, because you are estimating this, but this expansion, or this bracket, is this expansion. So you need to work out what x is first before you do the substitution. Don't just substitute that decimal in there. Okay, so hopefully you can see why I'm setting the red lines equal to each other there, because we're trying to estimate this. So we need to estimate it using our expansion. So set them equal to each other to find the x value that we need to substitute into there. So let's do that together, and hopefully it won't be too tricky. So let's do 1 minus x over 4 is equal to 0.975. Okay, I'm just going to use my calculator here so I don't get anything wrong. I am then going to minus 0.975 to both sides and add x over 4 to both sides to give me this. And I'll just double check this on my calculator. So that is 0.025 is equal to x over 4. Hopefully that makes sense what I've done. I've taken 0.975 over to here, and in the same step I have added x over 4 to both sides. Then if I multiply that by 4, I get 0.1. So I get 0.1 is equal to x. I'm going to write it the other way around. It still means the same thing. And then this is the x value that I'm going to substitute into there. I'm going to substitute it into my expansion. And I'll write that here. Sub into expansion. Hopefully you can see that is the x value we need to substitute, not this decimal into the expansion, okay? So that's the x value we need to substitute, so let's do that. And so 0.975 to the 10, and I'm going to use the estimation sign here. It's approximately equal to. It's not exactly equal to, okay? It's just an estimation because we're just using the first 4 terms. That's why it says here, use your expansion. Well, my expansion in part A was just 4 terms. So let's do an estimation using the 4 terms. And like I said when we were looking up here, this x to the 10 is kind of not really that useful if we add it on. It's not going to make a massive difference. So as we get more and more terms, substituting x equals 0.1 in is not going to make a massive difference to our estimation. Okay, that's how we can kind of think about it. But we're just using the first 4 terms because we've been asked to do that in part A. So all I need to do is just substitute in. We're going to have 1 minus 2.5 times x. X is 0.1, we've just worked that out. Plus 2.8125 times 0.1 squared minus 1.875 times 0.1 cubed, and that carries on, okay? The dot 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 signifies that it carries on, and I'm just going to pull the answer from the book. So we've done that there, and then this is what we get if you actually work out what they are. So that is then approximately, and it's still 0.975 to the 10. That's approximately this. 1 minus, hopefully you can do that multiplication there, 0.25 plus 0.028125 minus 0.00185 plus dot dot dot. Okay, then all you need to do is put that into your calculator. You could have put that into your calculator as 1 and it would have given you your answer straight away, but it's nice to kind of simplify each term to show you what you're doing. When you put that into your calculator, that is equal to 0.77625. Now, just notice the signs here. What I have done is I've used an approximation sign here. I've said this is approximately this expansion here, and it's approximate because of the first 4 terms in the expansion. We're not using all the terms. Then I've said, okay, simplify it, that is still approximately equal to that. But then I've used an equal sign here. And the reason I've used an equal sign is because the line above is equal to this. I have calculated what those 4 terms are added together, so it's equal to this. It's not approximately equal to 0.77625, it's exactly that, because that's what we've done in our addition here. So just make sure you get your signs right. It doesn't really matter if you put estimate or equal, it's just good practice to put the correct sign. So then we need to finish our answer, so all we have to do is give it to the decimal places that we needed to give it to. So 4 decimal places is what we wanted, and I always like to write a little statement at the end. We were trying to approximate, I'll put answer, so we were trying to approximate 0.975 to the 10, so it's not equal to, it's approximately equal to, so a curly equal sign. Approximately equal to this to 4 decimal places is 0.7763. Cuts off after 4 decimal places there, and then the 5 raises it to a 2. That is our approximation. So hopefully that makes sense, how you can take an expansion, get to first few terms, and then do your calculation so that you can estimate something quite easily.